So we talk about operator PMs though, we're really talking four categories that require a little bit lower skill set than a fully skilled, fully developed maintenance technician would be needed to do. And these are the kind of things that could be done at the operator level. Hey guys, this is Calvin Williams with Improver Technologies, and this is Feature Highlight. In this Feature Highlight video, we're going to talk about operator preventive maintenance and how Improver can help your business leverage operator preventive maintenance or operator PMs to drive outstanding business results. But before we talk about the software and the technology itself, let's talk about operator preventive maintenance. In this video, we're going to cover four topics. What is operator preventive maintenance? Why is it important? What are some of the commonly used approaches and how to get better results out of your operator PM program? What is operator preventive maintenance? PMs are the set of proactive and routine maintenance activities that are designed to prevent unplanned downtime and also reduce other types of losses. So we talk about operator PMs though, we're really talking four categories that require a little bit lower skill set than a fully skilled, fully developed maintenance technician would be needed to do. And these are the kind of things that could be done at the operator level. And those four things are cleaning, inspection, lubrication, and tightening. So let's dive into those a little bit. So when you clean, what you're looking to do is just remove contaminants, removing anything from the process or the system that does not belong. And cleaning is also done to prepare for inspection, right? So you'll hear the mantra in the lean and continuous improvement community that you clean to inspect. And there's tons of studies that will correlate the cleanliness of a manufacturing process or operation, or any operation. Cleanliness is directly correlated with performance and reliability as well. So there's tons of benefits that come along with cleaning. So you clean to inspect. The second stage here is inspection. So essentially what you're looking to do is identify defects or abnormalities. These are anything in the process that don't contribute to optimal performance of your assets, right? These could be misaligned parts of the machine. This could be worn down parts, worn gears, drive chains, sprockets, those kind of things. Missing pieces, missing parts, broken glass or broken plexiglass. Could be a wide variety of things that are contributing to a reduced level of output from the asset. And the other key piece to do here is, as part of inspection, is also to plan for corrective action. If you're a pretty skilled operator and you got the capability to go ahead and make the correction on the spot, and you have time to do so, then by all means, absolutely take care of that. Otherwise, you need to make sure you issue a problem tag, submit a work order, or in some way plan to address the defect. The third piece here is lubrication. This is just replacing the old grease or oil with new. No different than changing your oil on a car, for example. A vast majority of machines out there do require some type of oil or lubrication. You'll make sure you're doing that on a regular cadence as well. And the last piece here is tightening, where you're just resecuring or replacing fasteners. A vast majority of machines out there do have nuts and bolts, hinges, or various types of fasteners that are used to keep the machine together and allow it to move the way it's supposed to move. So tightening is also a key piece of operator preventive maintenance. Why are operator PMs important? And there's really three great reasons. One, it enables peak performance. Two, increases operator competency. And three, extends equipment life. All three wonderful things. So when we talk about peak performance, right? So if you're not doing preventive maintenance, then most likely what you're doing is some type of reactive maintenance, right? And this is what it looks like. This is what a manufacturing run in a reactive maintenance environment looks like, where you get the line up and going, something goes wrong, the line goes down, either all the way down or starts producing much lower than should be expected, and then you kind of struggle to get it back up. You may get it back up to peak speed, and then it goes down again, and you just respond to that as well. So this is what a production shift might look like, where you probably produce half of what you could have done with that same amount of time and resources consumed. But if you are doing some type of preventive maintenance or predictive maintenance, then it looks more like on this side, where you got the line comes up and it runs in a much more reliable and predictive fashion. You see there's a correlation between predictive maintenance and predictive operations. So the key takeaways here, you got to increase reliability and you get to address issues long before they result in failures. And that's a critical piece in all this, is because during cleaning, during inspection, you're going to see defects and abnormalities, and you can schedule the most appropriate time and the most economical time to address those issues when you're not using the equipment for production purposes. Increasing operator competency. So a big piece of operator PMs is it actually transform your operators into human sensors, where they're using sight, hearing, touch, smell. They're pretty much using all of their senses to determine if a machine is likely to fail in the near future, right? And during cleaning, during inspection, you're sort of getting deep into the equipment, taking it apart and seeing things, and you're seeing things out of place and out of alignment, and you start to say, oh, that's what that sound means, right? It means something's out of alignment, or you start to realize that the different sounds or things you see, or the temperatures or the vibration or the smells that you sense while you're operating equipment are tied to defects and abnormalities that need to be addressed before they result in failures for the process. The other big thing is it changes the way the operator runs the equipment. So if an operator starts to understand that their actions are contributing to downtime issues and defects and abnormalities over time, then this process gives them the opportunity to see that if they did their jobs a little differently, perhaps they can prevent future downtime as well. Last piece here, extends equipment life. You see the same thing with the vehicle. For your car, for example, if you're not changing the filters, not changing the oil, not changing the tires, over time, your car probably won't last as long as it's designed to last. The idea here is you actually want to maintain your car or maintain your assets or manufacturing assets in peak operating condition. I say manufacturing, could be any industry really. Could be computers also. Any type of technology requires PM. So when you maintain an asset in peak condition, you tend to get a much longer life out of the asset, and in some extreme cases could be double the lifespan. Here what you're doing is just removing contaminants, right? Contaminants cause problems. Oil, debris, dust, scraps of product could get caught up in the machine and cause problems. So here you're removing those contaminants. You're reducing stress on the machine. So machines, just like people, can only handle so much stress, and stress erodes the quality of the parts and the process overall itself. And the big piece here is you're also decreasing the total cost of ownership. An asset that's not well maintained is going to require more time and effort and energy to maintain. You pay the same amount up front, but you end up paying a lot more for assets that aren't being maintained properly. So what are some of the commonly used approaches to operator PMs? So before we dive into those common approaches, let me give you the framework of maintenance excellence just to set a little context, okay? So there's really 4 stages of maintenance excellence. First is reactive, and I wouldn't even classify that as excellent at all. First is reactive. Second is preventive, and that's kind of what we're talking here. Trust me, the difference between reactive and preventive is a whole world apart in itself. So going from here to here is a huge leap. The third item here is predictive maintenance. That's where you're actually using technology and sensors to detect their likelihood of a future failure, right? You're looking for things like misalignment, color, vibration, smell, even data analysis can be used to determine when a part or piece of equipment is likely to fail. So all of that kind of falls into the bucket of predictive maintenance. Last but not least, and this is ideally what you want to get to, is what's called prevention, maintenance prevention. And that's preventing the need for maintenance at all, right? So what that entails is designing your equipment or designing your assets in such a way that maintenance is no longer required. So you got to look at maintenance like a necessary evil, right? It's something you need to do until you can design or figure out a way where it's no longer needed, right? The intent is to get to a maintenance-free manufacturing environment. So with that said, under preventive maintenance, there's 2 main systems that I've seen used. Of course, there are some creative souls out there who have come up with more than 2, but there's the paper system and the digital system. The paper system looks something like this. It's usually a grid posted out near the line, ideally out near the line, becomes part of the visual workplace for that line. And essentially you got a list of items here and dates up here, and on a given day, it just kind of spaces out when each preventative maintenance action should be taken and by who. You may put initials in there to mark who completed the action. Again, it's part of good visual workplace element. A visitor to that area can quickly see what's being done, what's not, what's the health of the PM program. Some of the issues with this approach is that the administrative burden is pretty high, right? Somebody's got to design this sheet. Somebody's got to put it out there. When there's a change to an item, you want to add an item, remove an item, change an item. It could be quite a bit of work to do that, especially when you got a whole batch of them printed out. You may end up wasting. So yeah, there's a lot of lean waste or process waste involved in building and administrating a system like this. And also the historical record and the data, aggregation for a system like this can be pretty impractical, right? You need to know something that happened 3 or 4 months ago. It's not likely you're going to go through a whole stack of papers to dig out what happened and what didn't, and that kind of thing. So, and also the data, the historical record from a data standpoint can be a little bit impractical. On the other hand, there's digital systems, and this is actually what Improver provides for you in order to help you administer your operator PM program. So with this, you've got, again, a list of items. You can see what's been done, what hasn't been done. You can include other statistics like completion rates over time. You can have triggers in place to notify people, hey, you got to do this today. It's on your PM schedule. You can have triggers for supervisors to go do inspections. In fact, Improver includes a leadership standard work element where after 5 completions of a given item, or you can kind of set the number to say after so many completions, it'll trigger a supervisor to actually go out and inspect and validate that the work is being done satisfactorily. Just ask that visual inspection element. Yeah, the digital system integrates with other platforms. You got OEE over here, you got strategy deployment over there, you got problem solving over there. This allows you to integrate with those systems, so the systems, the processes you're using to manage your business can actually talk to each other. It takes a little bit of the burden off of the management side, administration side. Automatic data analysis, like I said, you can calculate completion rates and trigger various actions through the system. And then it's accessible and useful records. A lot of them include just a search functionality, right? You want to find a certain item, you want to look at a certain time frame, you want to make a change here and see how it affects your OEE or other key performance metric. Just gives you so much more capability to drive for the kind of results you're looking for. So let's talk about increasing the effectiveness of your operator PM program. So as with everything we discuss, it also fits within the PDCA framework. Like I said, all maintenance is a necessary evil. It's necessary because if you don't have it, you're going to have much bigger problems, and it'll drive your productivity into the ground. But it's not necessarily something that's good for your business in the sense that if you can reduce it or even eliminate it, then you should absolutely do so. So it's a non-value added but necessary set of activities. All maintenance activities should be sufficient. You should be doing enough, but you should be looking to continuously reduce the amount of maintenance work that you're doing. Regarding PDCA, so when you're planning your operator PM program, just a couple things to keep in consideration. You want to make sure that all of your effort is aligned with your overall company strategy, right? So you have limited resources. You need to use them in a way that's going to help your business move in the direction that it's going at the speed that it needs to go. Second, focus on the system constraint. So have a system view of your manufacturing or your business operation. Start with your constraint, right? And then you can expand out from there, maybe go to your second constraint and then third constraint and fourth constraint from there. And by doing that, you can start to see some immediate gains from the activity going into your operator PM program. Here's another key one I want to just put out there. Obviously, you'd have to use your better judgment to decide if this is the right thing for you to do, but if you're in a situation where you're capacity constrained, right? Let's say you run a 3-shift operation, you're just running all out to meet customer demand. You don't have a lot of time during the week to do PMs. And let's say you have PMs that should be done daily or every couple of days or something like that. You may want to consider scheduling production around PMs. Because if you don't, then what happens with those daily PMs is that you end up going back into reactive maintenance mode. Right? By them not getting done, you're essentially waiting to your production process fails in order to get those PMs done. So it'd almost be better for you to schedule time every day to complete your PMs, and then whatever time is left, you schedule production in those unique situations. Obviously, if you're not at capacity, you can do your PMs when the line is scheduled to be down anyway. Do, very simple, execute the plan as designed. Try not to embellish, because you can get into some bad habits that way, right? Judging whether or not you should do your PM based on how you feel that day. Probably not an optimal way to run your program. Check, evaluate effectiveness. And this is why it's key to have your PM program integrated with your other key metrics, and especially OEE, for example, like the digital system can do, like Improver actually does, is because as you make changes to your PM program, you should also see the result in the data. You should also see if it's producing the business result that you're looking for. And then lastly, act. So as you're going through and doing cleaning or inspection, it should trigger root cause analysis or corrective action. Secondly, consider design improvements. Can you design away the need for maintenance? Thirdly, consider predictive maintenance technology. If you install a sensor here, can you eliminate some of the PMs that are required to sufficiently maintain the equipment? And then lastly, experiment. You want to experiment with adding, modifying, removing some of your CILs or removing some of your operator PMs to see what true impact it has on your manufacturing process over time, right? Continuous improvement is the process of continuous optimization. So what is the optimal mix of PMs that works best for your business and the results you're looking for? All right, with that said, let's talk a little bit more about Improver technology and how it can help you drive a fantastic operator PM program. So like I said, Improver is a digital system. It's actually part of your digital action board. And you can create CILs, clean, inspection, lubrication items. You can create action items, assign them out, and it'll actually trigger for the work to be done when it's due. So an operator may go in and their list would say, here, you got these 3 or 4 things to do today. Make sure you get these done and mark them complete before the end of the day. Then it'll trigger their supervisor after so many completions to actually go and do a visual inspection to make sure the work is being done satisfactorily. And of course, Improver works within the PDCA framework, so it has metrics integrated in, OEE and other important metrics, has strategy deployment integrated, it has problem solving and so many other things, so that as you make changes to your operator PM program, you can easily measure the effect of your overall business results. So again, this is Calvin Williams with Improver Technologies. I really appreciate your time with the video. If you have any questions or any thoughts, make sure to leave a comment. If you like it, please do so and share it with others so that they can also enjoy the video. If you have any ideas for future videos, I'd appreciate a comment there as well. Other than that, thanks again for your time. Have a great day.